operations with functions. We can use the operations. By operations, we mean add, subtract, multiply, and divide, to combine functions together. So if we look at this first example, we have the function f of x equals x squared plus 4x minus 7, and the function g of x equals 8x plus 3. Adding and subtracting functions together is literally exactly what you think it would be. To find f plus g of x, we're going to take the function f of x plus the function g of x. So the function f of x is x squared plus 4x minus 7. And we're going to add to that the function g of x, which is 8x plus 3. Now, in order to combine these, I just collect my like terms to get x squared plus 12x. The 4x plus the 8x is the 12x. Then the negative 7 plus the 3 will give me minus 4. So the function f plus g of x is x squared plus 12x minus 4. Now, to find the difference of two functions, you're just going to subtract the functions. But remember, anytime you're dealing with subtraction, you've got to be sure you use parentheses around the second function, because the subtraction sign is going to change the sign of every term in that function. So my f of x is still the x squared plus 4x minus 7, but now I'm going to subtract from that 8x plus 3. So that means I have x squared plus 4x minus 7 minus 8x minus 3. Now when I collect my like terms together, I'm going to have x squared minus 4x minus 10. And this is the function f minus g of x. Now notice that both of these new functions are going to have the same domain as the original function. These are all polynomial functions. So the domain of these will all be all real numbers. Now let's look at multiplying and dividing. Here actually I labeled this adding and subtracting, but it should be multiplying and dividing. When we multiply the two functions together, f times g of x, we literally will take the function f of x and multiply it by the function g of x. Now for this particular problem, we get into a little bit of kind of lengthy algebra here, just simplifying the multiplication out. It doesn't get too bad though. In order to multiply these together, I just want to be sure I multiply every term in the first polynomial by every term in the second one. So the x squared times the 8x will be 8x to the third. X squared times 3 will be plus 3x squared. 4x times 8x will be plus 32x squared. And 4x times 3 will be plus 12x. Then finally the negative 7 times the 8x will give me negative 56x. And the negative 7 times the 3 gives me negative 21. So when I combine my like terms here, I get 8x cubed. When I combine my x squares, I have 3x squared plus 32x squared will be plus 35x squared. My 12x minus my 56x will give me minus 44x minus 21. And that is what I get when I multiply f times g. Now, division, you literally are going to put the polynomial f of x over the polynomial g of x. So this will give me x squared plus 4x minus 7 over 8x plus 3. Now, sometimes you might be able to simplify this a little bit. In order to simplify it, you would have to be able to factor and remove one of the factors that is the same from the numerator and the denominator. But here we can't do that. So this would be my final answer. The division here is really the time when you have to be careful about your domain. Because here we now have a denominator that we can't have equal to 0. So our new function here does not have the same domain as the original functions. The domain here is going to have to be everything that doesn't make the denominator 0. So to find my domain, I set the denominator equal to 0 and solve it. That would give me 8x equals negative 3. So x equals negative 3/8 is my bad number. So we would say x cannot equal negative 3/8. But x could equal everything else. Here I have some adding and subtracting again. Here my function f plus g is going to be the f part will be the square root of x plus 3 plus my g of x part would be 2x. Now in this problem I can't combine anything like I could on the last problem. So this is what I get when I add my functions together. This is my sum of f and g. Here at my domain I do have to be careful because I have a radical in there, so I can't use all real numbers here. Remember that anytime you have a square root, whatever's under that square root has to be greater than or equal to 0. So here my domain is that x has to be greater than or equal to negative 3. Or, closed interval, negative 3 to infinity. If I do subtraction with the same two functions, the only thing that's going to be different is the subtraction symbol before the 2x. So the domain, of course, would still be the same, because I still have to avoid the x minus 3 being negative. Oops, that's not a minus 3, that's a plus 3. I'm sorry. X plus 3 can't be negative. Now, to multiply these two functions together, it's just simply going to be the 2x times the x plus 3. And to divide the functions together, I would have the square root of x plus 3 on top and the 2x in the denominator. So the domain of the first function still is just avoiding the x plus 3 being negative. So x has to be greater than or equal to negative 3. And in the division problem, not only do we have to avoid the numerator being a negative under the radical, we also have to avoid the denominator being 0. So we can say that x has to be greater than or equal to negative 3, and x cannot be 0. So in interval notation, I would go from negative 3 up to 0, do not include the 0, and then start again at 0 and go to infinity, but do not include your 0 here. One more, let's take our product here and actually put a number in. Here's f times g. We just said that was 2x times the square root of x plus 3. I'll put parentheses in there so you could see it a little better. If I want to evaluate this at x equals 4, I can just put a 4 in. This is give me 2 times 4 times the square root of 4 plus 3 would be 8 times the square root of 7. Now let's take some find some values using our table. The x's are in the numerator, and the f values, f of x, are in the second row. I'm sorry, I think I said numerator. I meant the top row. And the g of x values are in the bottom row. So f plus g of 4, I can find that by doing f of 4 plus g of 4. So f of 4, when x is 4, the function f has a value of -1. And when x is 4, the function g has a value of 4. So -1 plus 4 would be 3. Now I want to find f times g of -2. So if x is -2, my f of -2 times my g of -2 would give me the -2 here times the 5 here. So that would be -10. And finally, g divided by f of 0 means I want to put g of 0 in the numerator and f of 0 in the denominator. So g of 0, got to be careful here, I want the g value on top, so that's the 2. And the f value on bottom is 0. So this one is undefined. It does not exist because we can't have a 0 in the denominator.